How you doing, everybody? Randy Richard in the shop. So in the previous video I showed you the fly rod tube end, and finally got around to making the cap for it. So that's what this video is going to be, is making a nice brass cap for the fly rod tube end. Actually, I make a plastic Del ring cap also for it. I was making and I made the Del ring cap as a prototype to the brass cap to make sure the threading and fits were all going to be good. It's kind of nice being able to do that sometimes, especially on something odd like this project where the pitch is 20 TPI, but the diameter is an odd diameter. So you have to calculate out your bore diameter, your minor and major diameter that you're going to use on it. So there's a nice way to do it is just prototype it first out of something that's inexpensive, and then make the final product. Brass is not cheap these days, so that's what I did. And I'm only going to show you making the brass one. I didn't even film making the Del ring one. So let's get on with the tube. I don't know the manufacturer of the tube, so we'll go from there. But anyway, that's it. Anyway, let's go watch the video and get the cap made. It's a fun little project. Thanks. So here's the rod tube end. The cap is going to thread onto. So I measured the outside diameter of those threads. 1.644. So now I'm going to measure the pitch diameter also of the threads. I've already measured them. Check the pitch. They're actually 20 threads per inch. So that's easy, just using a standard pitch gauge, right? Oops, there we go. Standard pitch gauge. Okay, so here's our tube end. There's our threads. Now we need to make a cap. Well, we need to cut threads in the cap, match these threads. But we don't know, these are, and I'll measuring this on the outside, the OD, it's a weird size. 1.644 is what I measured across the top of the threads. So we can consider that the major diameter. I used thread gauges to determine the pitch. And ended up, I tried metrics and all that. So, but anyway, it ended up being 20 threads per inch, right on the money. So that's good to know. So we know that. Now, there's a lot of good information out there. You could use the machiner's handbook. Okay, all the formulas. Everything is here to do all that, to figure all this out. Well, there are some shortcuts. So one thing I did do is I did measure with some wires using the 3-wire method, and I measured this to get the pitch diameter. Now I'm using a piece of pipe insulation foam. It's nice and pretty stiff stuff. And if you put the wires in at a slight angle, like that, there's 2 on this side and 1 over here, it'll act like a nice little spring, and you can just flip it right in there. Boom, boom. Get them in the threads you want them to be in, and it will actually stay there. And you don't even have to hold it. Pretty nice. You can do this over on the lathe when you're working on the lathe, and it will just stay there. And it gives you the opportunity then to come in with a micrometer and measure across your wires. So I did do that, and I calculated it out for what the pitch diameter is, and I calculated out what the pitch diameter should be, and it's about 6 thousandths too large right now. Just so I came up with the measured diameter, pitch diameter was 1.618, and the theoretical pitch diameter ought to be 1.612, so about 6 thousandths difference. They may have cut the threads a little tiny too deep, but that's okay. So we know that information. Anyway, so but some of their information is out there that is very helpful to speed you through a little bit of all this. This is from Newman Tools. They're up in Canada, and they have a lot of great. Let me find it here. Newman Tools Incorporated, Ontario, Ottawa, Ontario, Canada, Sittsville. Anyway, they have a website. It's Newman Tools. Yep. It's newmantools.com. I'll just write it down here. And they have a lot of technical information that can really help you, especially with threading and understanding how classes of fit and everything. I keep this in my little shop reference book, which I've shown quite a few times. And all I did was print out some of their information, and so I have it all in here with the charts and all this. But they give a really nice formula, or they have it worked out already into a table. We'll just pick 20 threads per inch. Here's the double depth of thread, what you would subtract from the OD of whatever you're working on, the OD of the screw. And in this case, it's 1.644. See, it's a weird size. But this is all based on the pitch of the thread. So if you want a 75% thread, so they got 60, 65, 70, 75, 80. We're going to zoom you in. So they have the percentages across the top, double depth of thread, and then your pitch. So we're choosing 20, because that's what our tube is. And we go over here and we'll do 75. So it says subtract 0.0485, so 48.5 thousandths from the OD. And we come up with 0.5952, something like that. So 1.595 is the minor diameter we want to bore our nut to. It's that simple. Like I said, they worked it all out. So the formula, if you want the formula, is also on here. The outside diameter of the thread, so you just measure across the threads. Subtract. Now this part here, oops, try. So it's kind of written out. There you go. So the outside diameter of the thread, subtracting, minus. Now this is all in parenthesis. So it's 0.01299 times the amount of percentage of full thread divided by the number of threads per inch. Now, when they say amount of percentage of full thread, you don't have to put in a decimal amount of the percentage. You can just say 75, just 75. So, or 60 or 65, whatever you want. Just don't convert it to a decimal. So, 0.01299 times the amount of the thread, so 75, divided by 20, subtracting that from the outside diameter of the thread. And you'll come up with the minor diameter of your hole you need. And that's all they did. That's what they did here. They just worked it out for the common thread engagement percentages on the table here. That's all they've done is worked it out, worked that formula out for you. But they give you all this information on their website, and if you just print out some of this stuff, it's really good. It's pretty easy to understand and such. So classes of fit and all that good stuff. So Newman Tools Incorporated, newmantools.com. If you want some extra information on threads and stuff. So I have my my miter diameter. Now this spreadsheet here, just to show you real quick, what I did is I made this spreadsheet up and worked out the minimum and maximum pitches using the PD wires, using your wires here, from 348 threads for all this all standard stuff, all the way up to 4-inch 16 threads. It's easy to do on a computer, you know. So these are all the standard threads and pitches that are normally used, and you know, I have down what class fit they are, you know, whether they're 2A, 3As, the pitch, the wire size you should be using for your PD wires, and then the calculated out for the pitch, maximum minimum pitch, what measurement you should get for that diameter screw or bolt or hole you're measuring. You know, like let's see here. We'll just look up. We're a quarter 20 for 3A or 2A fit. You know, your measurement across 029 wire should be 0.2601 to 0.2564. You know, it's quick. It's you can just look right it up. You don't have to calculate it out, and makes it a little faster to use. So anyway, so that's how I determine the bore diameter for the cap. So here's the cap we're going to build. I made it brass colored even. So the threads in here are 20 threads per inch, but the diameter is nothing standard at all. So I ended up having to measure the male threads, and so we're going to have a little counter bore right here for it to fit over the brass fitting on the end of the tube, and then we have a little counter bore here for thread relief as we cut the thread. So the total cap is going to be a little less than an inch, 0.9 or so inches. It really doesn't matter too much, other than to make room for the inside boring and everything. We're going to put a nice little radius on here and a little slope on this, and it should look pretty nice. Let's see here. We can see actually this does excellent job in rendering an object. Look at the reflection type setup in there. It's got a motorcycle, but really makes it look very realistic, and actually I'm really liking this program. Really fun to use. This is an Inventor. Okay, so I was showing you this, and I decided I'm going to test everything out on the sizing before I make it out of brass. So I made it out of Delrin right there, and I don't know if you can see inside. It came out really very good, and I think we're going to stick to the plan. I did everything, you know, a radius, the dome top, the whole 9 yards there. I did all the counter bore, relief, thread relief, everything. So here we go. You'll see that looks, goes right on. So the thread calculation is good. It just fits perfect, and I think that's going to look really nice. I might chamfer this a little bit more. So this is, you know, it's kind of nice to every once in a while have some Delrin around. It machines very well. It's fairly hard plastic, and the machine's great, but it's pretty inexpensive. And have some of it around so you can prototype something before you commit to an expensive material. And brass is not cheap, so we'll make this cap out of brass now, and I'll film it then. I didn't film making the plastic one. So let's go over there and let's get one made for real. Okay, I've got a piece of brass stock in here. These used to be legs on a bathtub, actually. I made them many years ago. And now we got the regular right feet for the bathtub, and so these are stock now. So I just finished it off. These are 1 7/8. So we're going to center drill it. I'm using a spotting drill here because I'm gonna drill in there a little bit, enough to get a boring bar going, and then we'll machine all the inside out. Then we'll cut on the outside and part it off, and turn that little cap around. But I've got the bed of the lathe cleared off, so I can take the tailstock all the way back, and I'll be able to get the tube up here. There's enough room to get the tube in, so I can test fit the thread. That makes it kind of nice. So I got a 1-inch drill in here. I only need to go a 1/2 inch from the very tip. I can go a smidge past that. So actually I can go 5/8 past the tip. Okay, we're set up for boring. I'm going to go in there, touch it off. I've already set the dial indicator for 650 thousandths of depth, and we're going to bore it way out, so got plenty to play with here. Remember, chatter is always bad. I'm down to the bottom, and I still need about 50 thousandths. So, yeah, I just need 50 thousandths. We're just going to see if I can just skim it, shave it out of there. Nice big chips. Okay, there we go. Nice flat bottom hole, and we'll be good. Okay, 100,000 depth to cut. Okay, we'll do a quick measure. See how we are. We still got quite a bit to go. Well, I'll just measure it. Anyway, we got 1,388. We got 1,595. So that's 207 thousandths to go. We won't do it in one. We'll do it in 2 cuts because we want that last one to be a nice finishing cut. We'll take out most of it. We'll take 180 of it out. Okay, we got about 28 thousandths to go, so we'll do that one cut, 14 thousandths. I slowed down the feed to give it a nice finish. Okay, we ended up at 1596. Good enough. We're that's just one over. It will work. Now we'll do the outside counter bore. We're going to do this just in one cut. We're just going to set that up there, touch the end, set our dial, 100 thousandths deep. Let's do this by hand, one cut. There we go. Not much, just a little bit. Now we'll go in and we're going to cut the thread relief. Okay, I went in half an inch, 500 thousandths. I'm going to come back out to the same dimension that I turned the counter bore, and then go all the way up to the bottom of the hole. First we'll bring it out. Okay, then we're just going to go over and I'm going to go in and just clean up the bottom of the hole nice. There. Just did a little skim on the bottom of the hole and it looks just right. We got a little groove and we have our surface here. See if I can point to it. So we got a thread relief in the back here. We got this spot here will be the threads, and then our little counter bore here. This part here, this counter bore slips over the ring or the threaded piece that's pressed onto the tube. So this is just where the threads are. Okay, I got a dial indicator down here on the ways for when I should stop, so I have plenty of room not to crash into the bottom of your hole. I'm going to touch off with the threading tool here. Now I'm not going to use the compound for this threading operation, so I have it set at 0 or 90 degrees, whatever way you want to call it. I have it set with the axis, so it's out of the way. And I'm just going to use the cross feed. So I'm going to touch off, zero my dial, and we'll just use that. This is going to go really quick. Probably 2 or 3 passes. And from the plastic one, I figured out the depth pretty close. So we'll do, a couple passes to the mark, and then we'll test it and see how it goes if we have to cut another cut. Okay, I got it down there at 200 RPM. We'll do this kind of slow. It's not very much distance and too nerve-wracking. There we go, we touched. 0 on my dial. We'll do a little scratch pass. And my feeds are all engaged. Oops, that's backwards. Okay. There we go. Okay. Now they're engaged and going in the right direction. That helps. Quick check. Should be right. Right on the money. 20 threads per inch. Yeah, I've already reset my dial. Let's put a little lube in there. Should be pretty close. I'll blow that out and we'll check it. Well, it starts about a thread, but tight, so another cut. Oh yeah. Oh, that is. Oh, that is absolutely perfect. You couldn't ask for better than that. Okay, I'm just going to run a little Scotch-Brite on it, chamfer the edges, do our cutout here, and we'll part it off. I'm not going to take very much off. I'm just going to take enough to round this so it's all concentric. That's all I'm going to do is just do a clean up on it. That looks pretty good. We'll do it for about an inch. Should give us enough room. About an inch and an eighth there. And there, that's cleaned up. That looks just fine. Okay, we're over here on the Logan Lathe. And I'm all set up here. We're going to cut the 5-degree on here first. Oh yeah, and pretty good. Now we'll do the radius. Not good. It looks really nice. Let's go try it on the tube. So there's two caps right there. They both came out really nice. Prototype one. This one I made just a little bit longer. It looks a little better, I think. And it's got some weight to it. A little dirt on the inside. Anyway, came out really nice. And that's just a little Scotch-Brite finish. Very happy with it. I cleaned up the end of the, buffed up the end of the tube. Both ends, the threaded end and the base. And let's see how it goes on there. Just like it was made for it. Right on there, just absolutely perfect. And that close tolerance fit there on that counter bore. Man, that came out good. So this is what I'm thinking. I'm going to give this to my fishing partner for a Christmas present. And I think I'm going to see if I can engrave his name on here. I think that would be really, really cool. Just a slight slope. I think the diamond engrave will do it. He doesn't watch my videos anyway. So I can tell you that on here. And so I think we'll diamond engrave it with his name and the year, I think. We'll give it to him as a Christmas present. And he'll have a cap. He can save this cap and use this one if he wants as a cap, beat around cap. So thank you guys for watching. Nice successful project, and I'll show you when if I can get it engraved. I'll show you that. I might test engrave this one, the plastic one, and then we'll see how that goes.